We are seeing a rounded diagram on our screen. We call that diagram a circle. Today our class will be confined only in circle. Most of the objects of this universe are shaped in this diagram. Hello, I'm Farhad. Today we are going to learn what is circle, how to draw a circle, and we are going to discuss the various different topics of related to circle. We are seeing some points on our screen. Today our class will be confined in these points. We will discuss all the points that we are seeing on our screen. We'll learn what is circle, what is chord, what is arc, what is diameter, what is radius, what is circumference, and some theorems based on circle. Let's get started. Well, what is circle? To have a circle or to draw a circle, we need 2 points. To draw a circle, we need 2 points. How many points? 2 points, 2 different points. One is fixed point. One is fixed point, and second point is moving point. To draw a circle, we need 2 points. One should be fixed and another can move around the fixed point. And there is a relation between these 2 points. There is a relation between these 2 points. What is the relation? What is the relation? The relation is the distance between the 2 points. The distance between the 2 points should be equal throughout or all over the diagram. To draw a circle or in a circle, we'll find 2 points. One is fixed point, another is moving point. Moving point can move around the fixed point, and the relation between the 2 points is that the distance between the 2 points should be equal throughout or all over the diagram. You can't ignore the relation. If you ignore the relation, it won't be a circle. So what is fixed point and what is a moving point in our diagram? Let's explore this. We have a fixed point. we can't change the position of that fixed point. Remember, you can't change the fixed point. You can't change the place or position of the fixed point. So we have taken a fixed point and now we need a moving point. That moving point can move around the fixed point. This is our moving point. This is our moving point. This is our moving point. So here is our fixed point and here is our moving point. We can't change the position of that point, but we can change the position of the moving point. But we can't move the position or change the position of moving point according to our wish. We can move the moving point randomly. We have to follow the relation we have seen earlier. What is the relation? The distance between the points should be equal throughout or all over the diagram. That means the distance between fixed point and the moving point should remain constant. The distance between fixed point and moving point should remain constant. Let the distance between the fixed point and the moving point be R. Now I'm following the relation. I'm moving the point. See, this tip is fixed in that point, this tip is fixed in that point, but I'm changing. I put the pencil on the moving point and gradually changing the position of the pencil. This one is fixed. I'm not changing it, but I'm changing the position of the pencil that I put on the moving point. See, I'm changing it. So this is fixed point and this is moving point. That means I can move the position of the moving point, and I'm moving it right now, but I'm moving it in such a way that the distance between the moving point and fixed point is constant in every place. Let at time 0 the moving point is here, and after 5 seconds the moving point moves its point and it takes its place in that position. Now if I measure the distance between the moving point and fixed point, it will be R, equal to that. Well, now after 10 seconds, let the moving point's position is here. Now if I measure the distance between the moving point and fixed point, the distance is also r. That means in any point, in any position or in any position, the distance between the fixed point and moving point remains constant. And that time we can call the diagram as circle. And we can call the diagram a circle. Understand? Hope you have understood what is circle, what is fixed point, what is moving point, and what is the relation between the fixed point and moving point. Now we will explore the various topics of circles hidden within it itself, that hidden in circle. First of all, we will see what is circle. The point that I called fixed point, we call that fixed point the center of the circle. The point that is fixed is called the center. We call the fixed point center. Well, what is center of a circle? What is center of a circle? The point that remains fixed in its initial position, we call that point the center of the circle. Okay, we have learned what is center. Then we will head towards the chord. What is chord? What is chord in a circle? What is chord in a circle? I'm drawing a circle. This is our fixed point. Let's call that point O. And every point on the surface or boundary of the circle is moving point. The point that I'm drawing right now, the points that I am drawing right now are our moving point. Happy points are moving points. We are learning what is chord. If we join any two points, if we join any two any two moving points, of a circle if we join any two moving points. That line is called chord. This line is called chord. What is chord? If we join two moving points, any two moving points of a circle, we call that line a chord. It can be anywhere. We can join any 2 points. Suppose I'm joining these 2 points, joining these 2 moving points, and this is also a chord. 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 Okay, if you join two moving points of a circle, you will find a chord. Well, we have learned what is chord. Now we'll learn what is diameter. What is diameter? What is diameter? Diameter is a one kind of chord. Diameter is a one kind of chord. Diameter is a one kind of chord. Then what is the difference between the diameter and the chord? Well, there is a condition to have a diameter from a chord. There is a condition for having a diameter from a chord. What is the condition? The condition is the chord should go through the chord should go or pass through the center of the circle. To be a diameter of a chord, the condition is the chord should go through the center of the circle. I have said earlier what is chord. If we join any two moving points, of a circle, the line that we have got is a chord. But we can't call the chord a diameter until the chord passes through or goes through the center of the circle. Let's demonstrate what I have said. In this class we will draw a lot of circle, so don't be bored. Well, I have drawn a circle. This is our fixed point, and we call the fixed point the center of the circle. Let's name the point O. I have said if we join any two moving points of a circle, we find we have a chord. Let us join these 2 points, and we have got a chord according to our definition of a chord. Now if the chord, now see, we can't call that chord a diameter. We can't call that diameter we can't call the chord diameter, because to be a diameter, the condition is the chord should go through the center. The chord should go through the center of the circle. Is this chord going through the center? Of course not. The center is here and the chord is here. The chord is far away from the center. But now if I join 2 moving points, of a circle in such a way that the joining line goes through the center. Here, if I join these 2 moving points, this point and this point, if we join these 2 moving points, we see that the joining line is going through the center, through the center. At first, according to the definition of chord, if we join any 2 moving points, we can call that line a chord. So according to our definition, this is also a chord. This is also a chord. Now since this chord is satisfying the condition of to be a diameter, now since this chord is satisfying the condition to be a diameter, we can call that chord a diameter. Why we can call that diameter? Why can we call that chord a diameter? Because this chord is passing or going through the center. That's why we can call the chord also a diameter. Now if you notice carefully, see, this one is also a chord. This one is also a chord, but it's not a diameter because it's not satisfying the condition to be a diameter. This one is chord, not a diameter. This chord is, this line is chord but not a diameter. But this line is a chord but also a diameter. It's also a diameter. Then what can you say? What can you say? following the diagram, you can say every diameter is a chord. Every diameter is a chord, but every chord is not a diameter. Repeat. Every diameter is a chord. Every diameter is a chord, but every chord is not a diameter. Now if I draw another diameter on this circle, this one is also a chord and also a diameter, because there is a moving point and there is another moving point, and if I join these two moving points, we can call that chord. But this chord is going through the center. That's why we can call that chord a diameter. So every diameter is chord, but every chord is not a diameter. Every diameter is a chord, but every chord is not a diameter. Hope you have fully understood the diameter and chord and the difference between chord and diameter. Our next point is, so we have learned what is circle, what is chord, and we also learned what is diameter. Now we'll see what is radius. When I was saying the definition of a circle, I gave a relation of the 2 points that we need to draw a circle, and the relation is the distance between the points, the 2 points, one is moving point and another is fixed point, should be equal, or you can say constant. The distance between the 2 points should be equal, or you can say constant, throughout or all over the diagram. Well, here is our circle. This is our fixed point and this is our moving point. The distance that we are saying, which is fixed throughout the diagram between the 2 points, fixed point and moving point, this fixed distance is called radius. This fixed distance, this constant distance is called radius. Similarly, this is also radius of the circle. This is also a radius of the circle. This is also a radius of the circle. this one also, this one also, and every distance is constant, every distance is same. This one is also R, this one is also R, this one is also R, everyone is R, because to be a circle this distance should be remain constant, and we call that constant distance is radius. Earlier we have seen what is diameter. What is diameter? Earlier we have seen what is diameter. This one is diameter, this one is diameter. If I half the distance, if I take the half of this diameter, we will find the radius of this circle. Similarly, or vice versa, if we twice the radius, we find the diameter. That means if we divide the diameter by 2, we find a radius. Vice versa, if we twice a radius, we find a diameter. So we have got a formula, that is radius is equal to diameter over 2. This is the relation between radius and diameter. Radius is equal to diameter over 2. Well, our next topic is arc. We have learned what is circle, what is chord, what is diameter, what is radius. Now we'll explore what is arc. What is arc? Let me draw another circle. Let me draw the circle by pen. Let me draw the circle with pen, not by pen but with pen. Well, I'm having a problem here. Okay. I'm not being able to hold the not being able to hold the pen with this instrument, so I have to go with pencil. Okay, let me draw the circle again in pencil. Well, now let me draw a chord. This fixed point, we call it center. Let we take a arbitrary chord. That is our chord. Now if you see carefully, this chord has divided the circle. This chord has divided the circle into two parts. This chord has divided the circle into parts. This is our peripheral points of the chord, and this chord has divided the circle in two portions. One is this, and another is this. This chord has divided the circle into two portions, this one and this one. We call that portion an arc. This is an arc. This one is an arc, and this one is also an arc. The upper portion is also an arc, and the lower portion is also an arc. So a chord divided the circle. A chord divided a circle into two portions. Each of the portions is called an arc. This one is called an arc, and this one is also an arc. Well, we have seen what is arc. Now we will discover what is circumference. What is circumference? Let me draw another circle. Well, this is our fixed point. We called it center, and here is our moving point, and this moving point is changing its position time by time. The moving point is changing its position. Let's imagine this is a car. Imagine this is a car, and it's moving in a way that it's moving. Let's this moving point a car, and you are driving the car, and you are moving in such a way that, or in a path that the distance between you and the fixed point is always fixed. Well, now if you complete the circle, means you are started from here and you are changing your position and following the way after a seconds or minutes or hour, you have reached there from where you have started your journey. You have started from here and you end at there. That means your starting point and ending point is same. So when you are moving following the relation, this distance always is fixed. So when you are moving in a way that you follow the relation to be a circle, the way or the path that you have created, the path that you have created is called the circumference of the circle. The path that you have created that path around the fixed point. You have created the path around the fixed point, and the path you have created, we call it circumference. So this is our fixed point and this is our circle, and this path we call it circumference. This path we call circumference. Okay, we have also learned what is circumference. Now we will see some theorem based on the circle. Our first theorem is on your screen. Our first theorem is saying that the line segment joining the center, of a circle to the midpoint of a chord other than the diameter is perpendicular to the chord. So what are the key points? The line segment. How to find the line segment? How to find the line segment? To find the line segment, we have to join 2 points. We have to join 2 points, but we can't join any 2 points. The theorem has fixed the 2 points, and the points are: one is the center of the circle and another point is the midpoint of a chord. So we have to find a line segment joining the center and the midpoint of a chord. And there is another condition our theorem has given to us. This is this chord, the chord that we have chosen for midpoint, the chord that we have chosen for midpoint, that chord can't be a diameter. That chord can't be a diameter. We have seen so far that every chord is not a diameter, but every diameter is a chord. We have seen every diameter is a chord, but AP chord is not a diameter. So we have to choose a chord in a way that is not a diameter. Well, now if we take such a line segment that joins the 2 points, one is center and another is the midpoint of a chord, and the line segment is perpendicular. The line segment is perpendicular to the chord. If we join the center and the midpoint of any chord except the diameter, the line segment will be a perpendicular to the chord. Let's demonstrate the theorem. This is our circle, and this fixed point we called it center. Let's name it O, and we have to take a chord in a way that is not a diameter. We can't take a diameter, but we can take a chord. This is our chord. We have chosen this chord. See, this chord isn't going through the center. This chord isn't going through the center, so it's only a chord. It's not a diameter. It's only a chord. Now, in our theorem, it says that we have to find a line segment. We have to find a line segment joining the center of a circle to the midpoint of a chord, such that we have to join the midpoint of the chord and center. We have to join the center and the midpoint of a chord. So to have the line segment, we have to find out the midpoint. We have to find out the midpoint of that chord. We have from our class, maybe class 6, in class 6, maybe you have learned how to find the midpoint of a line segment. I'm drawing it. I have taken a radius greater than the half of the distance of the chord. I have taken a radius greater than the half of the distance of the chord. And I am drawing two arcs on the both sides of the chord from that peripheral point, and I will also taking the same radius. I'll draw another two arcs on the both sides of that chord. If we join the intersect point, if we join the intersect point, we'll have our midpoint. We'll have our midpoint on our targeted chord. Well, now we have our midpoint. We have our midpoint, and we will also have our center. Now, if we join the midpoint, and the center of the circle, we will have that line segment. We will have that line segment that the theorem has asked to draw to prove the theorem. This is our line segment. What have they asked to prove? They said, let me read the whole theorem again. The line segment joining the center of a circle. Line segment, we have got the line segment already. Joining the center of a circle to the midpoint of its chord other than the diameter. Okay, we have followed every condition. They said that the line segment is perpendicular. The line segment is perpendicular to the chord. The line segment is perpendicular to the chord. Perpendicular means it will create 90 degree. It will create 90 degree to the chord or with the chord. So here is our line segment joining the center and the midpoint of the chord, and this line segment is perpendicular. This line segment is perpendicular to this chord. This line segment is perpendicular to this chord. That means the angle between this line segment and the chord is 90 degree, and also the angle between this line segment and this chord is 90 degree. We have to prove that logically. That this angle is 90 degree. We have to prove that logically that this angle is 90 degree. We will, inshallah, prove that theorem logically in our next class. By then, we are taking leave for today. Next class, inshallah, we will solve 2 or 3 theorems based on circles. By then, till then, goodbye. Assalamu alaikum wa rahmatullahi wa barakatuh.